Okay, hello guys, welcome back to my YouTube channel. I'm Melvin Colley, an engineer and a mathematician. Okay, today I will give you some basic concept on how can you find the eigen values and eigenvectors of 3 by 3 matrix. Please watch my previous video. I talk about finding the eigenvalue and eigenvector of 2 by 2 matrix so you can get a basic concept. Okay, so before we go into the history of this, I would like to answer some of these questions from my subscribers. The first question says, who is your role model in mathematics? My role model is Scott Fetchikos. When I was in high school, I read a lot about him, and his work inspires me a lot. He's considered as the prince of mathematics. He did a lot of work in civil engineering and a lot of mathematics. And besides, he was born in 1777 in Germany. And then the second question says, you did win the best thesis award at the Florida International University. What was the research all about? Wow, you are a man. Yeah, it's true. I worked very hard. My work basically my research was something in harmonic with. Yeah, it was kind of fascinating. And then the last question says, not the last question, but I'm taking the last question says, which mathematics course or courses did you find difficult during your MSc study? Well, say I would say the Fourier analysis because my professor gave me like a 14 chapters. So I had to read them by myself, and yeah, it was kind of challenging. Yeah. All right, so there are a lot of questions, but I think I've answered these 3 questions for now. So let us get started. Let's go into today's lecture. I'm using my electronic pen, and I'm sorry my computer is a touchscreen, so I have to bend it over. You're going to hear some sound so that we can get started. Okay, so I'm sorry for the disturbance. Okay, so let me share the whiteboard. Okay, so I'm going to make the screen bigger, and this one can move up here. So this lecture. Okay, so um, I'm going to give you the history of that at the end of this video. So the first thing, in case you were given this matrix, I'm going to choose something at random. Let's see, maybe we can take -1 and let's make this 2 and see what happens. Okay, let's take a simple stuff like this. Okay, so I want you were asked to find eigenvalue and eigenvector of this 3 by 3. Why this is a 3 by 3? Because it has 3 rows and 3 columns. I will give you a history of this eigenvalue and eigenvector at the end of this video. So the first thing we have to do, we have to find the characteristic. I'm sorry for the noise in my background. So we know that the determinant of A minus the scalar times the identity is equal to 0. So remember for 2 by 2, what becomes the identity is 0 and 1. So for 3 by 3, what becomes the identity? 1, 0, 0, 0, 1, 0, 0, 0, 1. The main diagonal is 1. So we are going to multiply this by lambda. But remember, after if you multiply this by this lambda here, everything in here you have lambda, lambda, lambda. So after that, we say the matrix that is A minus this portion. Where are we heading? In other words, the main diagonal, we just subtract lambda. Okay, so I'm going to do that. So here, I'm going to have 1 minus lambda minus 1, 0, minus 1, 2 minus lambda minus 1, 0, minus 1, 1 minus lambda. Okay, so after finding the determinant here, at the end of the day, you will have this. So there were results. Okay, so what happens next is you can use the Cramer rule, or you can use what we call the cofactor expansion if you wish to find the determinant here, to find the characteristics equation. So what I'm going to do, I'm going to write this down. So here is 1 minus lambda minus 1, 0, minus 1, 2 minus lambda minus 1, 0, minus 1, and 1 minus lambda. Okay, so you can decide which rule you want to use. I'm using the Cramer rule, so yeah, I'm repeating the first two columns. Minus 1, 2 minus lambda, 0, and minus 1. Okay, so you saw this in high school. These lines, be very careful. Okay, so if I multiply all here, I'm starting for, remember, here is negative and here is positive. So I will have 0 times everything here is 0. Minus 1 times minus 1 is positive. 1 times that is negative 1 times 1 minus lambda. So on the tail, we'll have minus 1 times minus 1 positive 1 times that negative is minus 1 times 1 minus lambda. And then we come this way. So we have plus 1 minus lambda times 2 minus lambda times 1 minus lambda. So if we multiply this portion, it goes to 0. This portion, because of 0, all go to 0. So all will go to 0. So I'm going to erase, we'll have space. Okay, so I want to partition the board here. Okay, so let us simplify this expression here. I will have 0 minus 1 times 1 minus 1 minus 1 times lambda plus lambda minus 1 times 1 minus 1 minus 1 times minus lambda plus lambda. So remember, I'm multiplying here all of this stuff. So I'm going to keep this one and multiply these two. Plus 1 minus lambda times 2 minus lambda times 1 minus lambda, all will be equal to 0. So if I do simplify here, minus 1 is negative 2. And then I have lambda plus 2 lambda, and then plus 1 minus lambda times this 2 times this 1 is 2. 2 times minus lambda minus 2 lambda minus lambda times 1 minus lambda and minus lambda times minus lambda plus lambda squared, all will be equal to 0. So now we have minus 2 plus 2 lambda plus 1 minus lambda times, so this 2 here I can write him as 2 minus 2 lambda minus 3 lambda plus lambda squared, all equal to 0. So we can multiply this same by this expression. So minus 2 plus 2 lambda plus 1 times 2 is 2, 1 times minus 3 lambda 1 time plus lambda squared is lambda squared minus lambda times 2 minus 2 lambda minus lambda time minus 3 is 10 plus 3 lambda squared, and minus lambda time positive lambda squared will give us minus lambda cube, all equal to 0. Let me rewrite that correctly. Minus lambda cube erase minus lambda cube, so minus lambda cube. Okay, so all will be equal to 0. So if we simplify further, now let us look for, we have 1 lambda cube, so we can take it from there. So let us look for the square. We have this, so 3 plus 1 plus 4 lambda square. So let us look for the lambda. We have 2 minus 3 is minus lambda minus 2 lambda is minus 3. And then this minus 2 and positive 2 can go out. Okay, so all will be equal to 0. So we can multiply this equation by negative 1. So we have lambda cube minus 4 lambda squared plus 3 lambda, all will be equal to 0. So now we have this equation. What I'm going to erase this equation to have space, but I'm going to keep something I won't forget. That is this equation, this expression is yeah, because I will need it. Okay, so if you look here, we can factor out lambda. So if we factor out lambda here, we will have lambda squared minus 4 lambda plus 3, all will be equal to 0. So in other words, lambda equal to 0, lambda squared minus 4 lambda plus 3, all will be equal to 0. So if we factor out this, it becomes lambda minus 3 times lambda minus 1, all will be equal to 0. Okay, so what happened? Lambda here equal to 0. This guy will have lambda here will be equal to 3, and lambda here will be equal to 1. So remember, these are the values. So what we are going to do for each of these values, we need to find the eigenvector. So I'm going to start with 0. So I'm going to erase this portion. I'm going to erase this portion so I can have more space. I'm sorry for the details in the background. Okay, so Let me draw my line. Perfect. So at lambda equal to 0, so what we are going to do from this equation, we are going to replace lambda with 0. So our new expression we will have here becomes 1 minus 0 is 1, negative 1, 0, minus 1, 2 minus 0 is 2, minus 1, 0, minus 1, 1 minus 0 is 1. So this expression, term of s1, s2, s3 all equal to 0. So what I'm going to do, remember this is a system of equation. This can be written as x1, take the coefficient, x2 all will be equal to 0, plus x1 plus 2x2 minus x3 is equal to 0. 0x1 minus x2 plus x3 all equal to 0. So you have the system, right? You have seen the system. So what I'm going to do, I'm going to take two of the system only and use the Cramer rule to solve. So I'm going to take s1 minus s2 plus 0s3 equal to 0 and minus x1 plus 2x2 minus x3 all will be equal to 0. So I'm going to erase the other side of the ball, or I can petition here. And so I can just perfect. So I'm going to use x1 equal minus x2 equal s3. So I'm using the Cramer rule here. So remember, if I put a vertical line, I draw a vertical line on this, that means this is no longer existing. So what I'm going to focus on will be these two. So minus 1, 0, 2, and minus 1. So if I draw a line here, that means this will also have 1, 0, minus 1, minus 1. So I have 1, 0, minus 1, minus 1. And then for the last, if I draw the vertical line, cancel this out. 1 minus 1, 1 minus 1, minus 1, and 2. Okay. So you know that this is, I'm sorry, true. Okay. So here is negative, you know that, and the line going up is positive, is negative, and this is positive. So it implies for all. So 2 times this equals 0, minus 1 times minus 1, positive 1. So for this second, remember there's a negative attached to this x2. So in other words, when you find the determinant here, it should be multiplied by negative. So minus 1 times 0 equals out. Minus 1 times positive 1 is negative 1 times this negative. This goes to positive 1. And then minus 1 times minus 1, positive times the negative, negative 1. So 1 times 2 is 2, 2 minus 1 is just 1. So at lambda equal to 0, what becomes our eigenvector? So s1 is 1, s2 is 1, s3 is 1. Okay, so let us look at let us find the other eigenvector. So I'm going to erase this portion. I'm going to erase this portion. Okay, let me just take all this. Okay. So I'm true with 0. Now I want to know I'm free. So at lambda equal to 3. So wherever I see lambda, I'm going to put 3. So 1 minus 3 is -2. Minus 1 and 0. Minus 1. So 2 minus 3 is -1. Minus 1. So 0 minus 1. 1 minus 3 minus 2. Perfect. So as I told you earlier, this can be written as -2 x1 minus x2 plus 0 x3 all be equal to 0 for the system. Minus x1 minus x2 minus x3 will be equal to 0. So 0x1 minus x2 minus 2x3 will be equal to 0. So as I told you, you can use the two equations, first two equations. So this becomes -2 x1 minus x2 plus 0 x3 is equal to 0. So minus x1 minus x2 minus x3 all equal to 0. So we can use the same approach. So I'm going to erase this portion. I'm sorry. Okay, I'm going to keep everything here. Okay. So this time around, remember, if I put a vertical line here, this goes out. So I'll have this thing and this thing. So let me erase this one. Okay. So if I put a vertical line, that means I'm canceling this out. Yeah. So we have -1 and 0, -1 and -1. So if I put a vertical line here, -2 and 0, -2 and 0, -1 and -1, -1 and -1. So if I put this line here, -2, -1, -2, -1, -1, -1, -1, -1. Okay, so I will have, if I simplify this thing, remember my negatives, they remain constant, so this goes to 0. This time this value, I have +1. So this goes to 0, -1 time -2 +2. So this goes to yeah, so this is -1 times this +1, +1 times -1, -1 times -2 +2. So this and this will give us +1. So here remember this is a negative sign, so we fit this. So I will have 1, -2, and 1. So at lambda equal to 3, this becomes our eigenvector. This becomes 1 -2 and 1. So let me erase this portion. So we want to find another one again. So I'm going to erase this guy here. Okay. Okay, so I'm going to take these guys out. Okay, perfect. So what I'm going to do this time around, I want to know, let me erase this one because I want to know at lambda equal to 1. So at lambda equal to 1 this time around. So I'm going to put 1 minus 1 here becomes 0, minus 1 and 0, minus 1. So 2 minus 1 is 1, minus 1. So here becomes 0, minus 1, 1 minus 1, here becomes 0. So remember this can be written as 0x1 minus x2 plus 0x3 or equal to 0, minus x1 plus x2 minus x3 or equal to 0, 0x1 minus x2 plus 0x3 or equal to 0. So we have the system, but remember I'm going to take just 2. So I'm taking 0x1 minus x2 plus 0x3 all equal to 0, minus x1 plus x2 minus x3 will be equal to 0. So I'm going to erase this portion. Okay, perfect. So so what happens again if I put if I put a vertical line here? Then I cancel this out. So what happens? I will have minus 1 and 0, 1 and negative 1. So if I put a vertical line here, 0, 0, I will have 0, 0, minus 1, minus 1. And then if I put a vertical line, 0, minus 1, and minus 1, and 1. So let us find here the determinant. And so I can erase this one. Okay. So here becomes 0, is out. So minus 1 times minus 1 positive 1. Here is 1. So 1 times 0, this one go to 0, everything. So there is no need to add a sign because it's 0. So minus 1 times minus 1, positive 1 times this is negative 1. So 1 times 0 is out, so we have negative 1. So what? So at lambda equal to 1, how will we have for our x1, x2? So 1, 0, negative 1. So let me clean from here, let me clean this guy. Okay, so this is how you find your eigenvalues and eigenvector. Okay, so let me, I'm sorry for the noise because I have to pen down my computer. Okay guys, so basically you use this approach whenever you have 3 by 3 matrix. Okay, and someone may ask, what are some of the applications? Okay, now for instance, if you were let me give you some examples. In financial data analysis, we talk about eigenvalue. For instance, in engineering, when we talk about the design of bridges, what comes into mind again? We talk about eigenvalue and eigenvector. They are also used in the design of bridges. Um, and a lot of applications. So this is very important. Okay, so I hope this video helps. I'm coming up with more videos on pure math and applied mathematics. This is applied mathematics. So guys, welcome to my YouTube channel, and please share the video, subscribe, and like the video. So I have some videos coming up in civil engineering for saw mechanic, advanced saw mechanic, okay? Because we use a lot of linear algebra there. And also for engineering, I will also talk about composite foundation, okay? So guys, please subscribe so that you can get notification whenever I upload these videos. So thanks a lot. As I said, the history, eigenvalues and eigenvectors, they were invented by a mathematician. He was an English mathematician by the name of Arthur Carley. Arthur Carley was he invented that, and he is also considered as the father of matrix. And what is a matrix? We know that matrix is a rectangular array of numbers enclosed in a bracket. Okay, so I'm sorry, my pen. I have to use my pen. It's like hard to write on the screen. But when I get back to Miami, I'm going to do the remaining videos on the whiteboard. So thanks a lot, guys, and Merry Christmas and a prosperous Happy New Year. To my Chinese friend watching, I want to say 现代快乐，新年快乐. So see you later to my Spanish friend. Hola, hola, hola. So see you later, guys, and thanks for watching. Please share the video. See you in the next video.